Okay, so today we're going to start talking about 1.1 rectangular coordinates. Okay, so the screen sharing is not working if I put it in present, but I can just show it like this for now. Okay, so we're going to start with the Cartesian plane. The Cartesian plane is basically the same thing as the rectangular coordinate plane, and it's named after a mathematician, René Descartes. So basically, the Cartesian plane is what you've been probably seeing since like elementary school. The x-axis, the y-axis, the coordinate pairs like 0, 0, and 5, 2, with the 5 being the x coordinate and the y coordinate being 2. And you have to know that there's an origin at 0, 0. And you have to also know different quadrants, like quadrant 1, quadrant 2, 3, and 4. And the different like plus and minuses, it's the sign of the coordinate pair based on the quadrant. If you look here, that's positive. So both those values will be positive. And here, for example, it's negative and positive. Hence, it'll be negative and positive here. And that's always reflected in the coordinates. Like for example, in quadrant 4, it's 1/2 comma negative 3, which is reflected here. Oops, sorry about that. Okay. So the Pythagorean theorem. So basically, this is used for right triangles. If you look over here, that's 90 degrees, 45, and 45, all adding up to 180 degrees. But all you have to notice is it's a right triangle because it has 90 degrees right there. So this is A, B, and C. It doesn't have to be exact. This can be B, this can be A, but this is always C. The hypotenuse is always the greatest side. Okay, so basically what happens is you have to plug in parts of the formula to get the other side. So if you're trying to solve for A given 10 and 8, you would put A squared plus B squared equals C squared, and you would plug in all the values, and you would end up with A squared equals 36. Problem is we're not looking for A squared, we're looking for A. So you would have to square root both sides, and you'll get A equals 6. And if you look at it, 6 and 8 are both less than 10. That's because the hypotenuse, or C, is always the greatest side. Now for solving for C, it's the same method. You just plug it in. It doesn't matter which one is B and which one is A, 5 or 12, as long as C squared is on the other side. And you'll end up getting 13. Those are the examples. Okay, so distance formula. So basically, it's what the name is. It's finding the distance between 2 points. So we're finding distance between x1 and y1 and x2 and y2. And the bottom one, it's not a square root, it's not an exponent, it's just a subscript. Basically, it's like naming it. So that's the formula, and I'll show you how to apply that in the next slide. So if you're finding the distance between 2 points, in this case, these 2 points, you would have to plug it into the equation. So first you have to assign x1 and y1. In this case, -2 and 1 are x1 and y1. Doesn't really matter which one you choose as long as it's the coordinate pair that goes together. And here x2 and y2. So I'm going to choose x2 and y2 and x1 and y1. You can do it the other way around, but this is what I'm doing. And you have to plug in the values. So if you look at this, x2 is 3 and x1 is -2. So if you're plugging in that, it would become 3 minus, as that part of the equation, -2. So remember, double negative becomes positive. 3 minus -2 is 5. 5 squared, and you would solve for it, and you would end up getting this. That's the distance between this point and this point. If you look at it, you can see the Pythagorean theorem in play, actually, because you're seeing the distance between 2 and 3, which is basically 5, and the distance between 1 and 4, the y values, which is 3. So 3 squared plus 5 squared would end up equaling c squared, and c would end up being 5.8 since you're using the right triangle again. But the distance formula is probably easier to process. Now the midpoint, now the midpoint formula, it is exactly what it sounds like. You're finding the midpoint between 2 points. Before, you were trying to find the distance or the length or how long this is, and now you're finding what's smack in the middle. So what's the easiest way to do that is, if you look at this before looking at the equation here or anything, the midpoint is somewhere, it's halfway between the x values, between 9 and -5, that's about 14 units apart. divide that by 2, they're 7 units apart. -5 to 2, that's 7x units apart and 7x units apart. So basically, in terms of x, it's right in between. Same thing for y. 3 and -3, they're 6 apart. So 6 divided by 2 is 3. So if you go 3 units up, that's the midpoint, 3 units more up, that would be the other point. But if that's too confusing to understand, what's more easier way to process is x1 and y1 again. Again, this can be x2 and y2, and this can be x1 and y1, but this is how we're doing it right now. So you would just plug in the values as you did last time into the midpoint formula, and you would end up getting the value. Yes, okay. So there's some applications that are probably good to know for this. So basically, a football quarterback is throwing from the 28-yard line. This is a 28-yard line. In this case, they made that the x-axis. So that's the 28-yard line. And no, I'm sorry. The 28-yard line is the y-axis here. Because if you're going all the way to 28, that's where the quarterback is. And then 40 units this side. So this is the sideline. He's 40 units from the sideline. And then the wide receiver catches it on the 5-yard line, again the y point, and 20 yards from the same sideline. So the x is 20. So now you just have to plug in the points. So you have to understand what the actual points are first. It's 40, 28 because that's where the quarterback is, and 20, 5, and that's where the wide receiver is. The main thing is you have to be able to, I guess sketching it always helps. If you can sketch this, that's all great. In this problem, they provided the figure, so you don't have to worry about that. So now you just have to plug in things into the distance formula, which you had to simply memorize. And that's it. So you square root it and you end up getting, it's about 30 yards long. So that means the quarterback threw the ball 30 yards before the wide receiver caught it. Okay, now translation. Translation means you're simply moving the graph or the points to the up or down, left or right. It doesn't really matter, but that's what translation is. So in this case, before we even look at what the actual problem is asking, if you notice, the shape of both graphs are the same. What's changing is these endpoints right here, right? So that 2, 3 is going up and over a little bit. So if you look back at the problem, it says shift the triangle 3 units to the right and 2 units up. So if I go 3 units to the right over here, 1, 2, 3, and 2 units up, 1, 2, I would end up getting a point on 4, 0, and that's reflected here. This is a translated graph. This is the one that goes 3 units to the right and 2 units up. And I'd basically apply that to all three. If I want to do it using, if I want to do that using the actual coordinate pairs for all those three, visually. But there's another way to solve for that because sometimes it can be pretty ambiguous. It can be right in between. It can just look weird. So you can do, if you have these vertices, you can do this without even having a graph. So basically, if you're shifting it 3 units to the right, if you're going to the right, that means you're adding to the x-axis. So if you're going at 2, you're going to the right 3, it becomes 2 plus 3, and that point ends up at 5, 5. So what happens here is if I'm going 3 units to the right, I would add that to the x points for all 3 of them because you're going to the right. If you go to the right, it's becoming more positive, you're adding. So that's the thing. And if you're going up 2 units, 2 units up, that means you're going up, which is impacting the y point. If I was just having 2, 3 and I went up 5 points, that means the y is increasing, but the x is not since you're going up. In this case, you're doing both. You're going up and over. So here you would have to add +2 for the going up to the y coordinates. And you would end up doing that for all 3 and you will get these new pairs. So the overall idea is this is all on the Cartesian plane, the rectangular coordinate planes. It's the points you've been using for a long time, but there's some few key things that you can understand using all this. The main thing you have to also understand is in the future, there'll be different kinds of graphs. But for now, this is all you have to worry about. Thank you, and I hope that helped.